delighted to announce the opening of our new facility for the Operations and Maintenance Centre of Excellence. Situated within the port of Grimsby, we have located ourselves at the heart of UK operations and maintenance for offshore wind. With planned investment of over £35 million in the next 5 years, we are committed to aligning our services to the needs of this growing sector.
I'm very pleased to personally welcome the Operations and Maintenance Centre of Excellence to its new facility within the Port of Grimsby. Offshore Renewable Energy Catapult's move is a reflection of Grimsby's leading role in offshore wind, one of the UK's fastest growing energy sectors. We have a long and proud maritime heritage, so it is testament to our town's ambition that we have transferred our skills and expertise to a major and long-term industry in offshore wind.
Our move comes at an absolutely critical time, not just in support of the growth and prosperity of our own industry, but also for the UK's green economic recovery and progress towards our net zero goals. The Operations and Maintenance Centre of Excellence will play a central role in this, collaborating with key industry stakeholders, UK supply chain and academia to accelerate new and innovative technology and best practice for wind energy in the UK. This will focus on accelerating some of the most advanced solutions to the market in areas such as robotics, autonomous systems, artificial intelligence and predictive maintenance, which will serve to enhance the UK's status as a world leader in offshore wind. In turn, our activity will help to drive economic growth, particularly across the supply chain, utilising skills and expertise from other strong UK sectors such as automotive, aerospace, oil and gas, defence and data and digital. This will be vitally important in job creation and building long-term economic resilience.
Our port is already home to some of the industry's biggest players, and we are perfectly located to service the world's largest offshore wind farms in the North Sea. By working closely with ORE Catapult, we can continue to attract inward investment, create high-value jobs, nurture innovation, and develop our local supply chain. This is an incredibly exciting time for Grimsby and the Humber offshore wind cluster, and I look forward to working with ORE Catapult as we continue to make Grimsby and the UK a global leader in offshore wind operations and maintenance.
I'm very excited by this next evolution of our Operations and Maintenance Centre of Excellence, and I look forward to the team continuing their fantastic work to keep our industry at the forefront of the UK's clean energy strategy.
Good morning, everybody. We're just setting up the screens here. 1 second. Fantastic. I think we're working. Catherine, can you just give me a thumbs up? Can you see that? Great. Thanks very much. Well, thanks everybody for joining us today. And obviously thanks for traveling all the way to your home office in most cases to be with us. Welcome to the virtual launch of the Operations and Maintenance Centre of Excellence facility in Grimsby. While we are working from home at the moment, we obviously wanted to do this in person, but there we are. We are very keen to physically welcome you to the office when we return, and we'll obviously keep you posted and let you know when that occurs. My name is Ben George. I'm the General Manager for the ORE Catapult's activities in the Humber. The main one being the O&M Centre of Excellence. For me, I joined the Catapult in November last year and was previously with the ORE Low Carbon Program at the University of Hull. Prior to that, I had a background in military aviation and systems development, both here in the UK and in Australia. Today, as far as what we're looking to cover, we're going to be providing an introduction to the OMCE, as well as going into more detail about just some of the activity we're involved with across the industry. It's close to a full day. We make no apologies for that, and we're really only just dipping our toe into the breadth of what we do and what we get up to. A little later, Catherine York, the OMCE Operations Manager, will cover a bit more detail in today's agenda and the plans for the future showcases, so that you have plenty to look forward to once we finish today's activities. All right. As far as the rules of engagement for today are concerned, you can drop in or drop out as you see fit, and depending on the agenda, which parts are of particular relevance to you. The whole thing's recorded, and we'll have that available on the website at the end. So as far as asking questions throughout the day, if we could please use the Q&A function on the Zoom taskbar at the bottom. And the chat function is really only for administrative functions or specific questions that you need to keep you going. So without further ado, I'll just give a very quick bit of background on the Catapult network and the ORE Catapult before we get into more detail on the OMCE. So the Catapult network was established by Innovate UK in 2011 and is a network of 9 technology and innovation hubs in over 30 sites across the UK. The real focus is to bridge the gaps between research and industry and bring UK innovation to life. So the ORE Catapult is just one of those 9 functions. As far as the Catapult is concerned, the 2 key numbers that I really wanted to get across here is the industry partners in the top left at 5,300 for 18-19, and in the bottom right, over 15,000 SMEs have been supported across the Catapult network in 18-19. All right, the offshore renewable energy catapult specifically. So we have over 200 engineering, research and sector experts and world-leading test and demonstration facilities over 8 centres across the country. We also have 3 UK academic research hubs, and so with universities of Manchester and Strathclyde, Bristol and Sheffield. And we also have International Research and Innovation Centre in China. Again, impact. What's the Catapult been up to in 2019-20? Again, the numbers that I wanted to bring to your attention, over 235 SMEs have been supported in that year alone, and 44 companies supported with product development. All right, now we'll get into the specifics of what we are doing in Grimsby. So the Operations and Maintenance Centre of Excellence in Grimsby has demonstration facilities, collaborative space, and we're based in Grimsby because it's the UK's key offshore wind O&M port. It also gives access to the Catapult, and not just to the ORE Catapult, but to all the Catapult network through Grimsby to industry. And we're really focused on building capability and presence with a specific focus on operations and maintenance. So where are we? Just off the A180 in Grimsby, in the port itself. So basically just prior to coming into the port facilities proper, the O&M Centre of Excellence is in the Port Office building. We've got that middle floor there, the first floor in the Port Office building, and that's been just been finished renovated and waiting for us to return to the office. So our real focus is for the UK to be the global leader in smart O&M. So By doing that, really focusing on a national centre of excellence for O&M innovation and demonstration, and being that hub and spoke to all of the other clusters and all of the regions really of the UK. We have already, the Catapult already has 30 FTEs working in O&M. We've got a history of 70 projects across the Catapult in O&M to date of greater than £40 million worth of value. Right, our real objectives for setting up the OMCE in Grimsby are to give that thematic and physical focus to O&M, which is often considered a bit of a, well, I wouldn't say an afterthought, but an aside, really. It's not quite as attractive in the initial stages as all of the planning, the deployment, and getting the offshore wind farms actually up and running, but the O&M is the tail that keeps wagging for 25 years. And it really needs a strong focus to build that capability in the UK and keep us at the forefront internationally. So we're stimulating collaboration and realising that innovation. We're really focused on building that UK PLC content for domestic growth and for export. There are massive export opportunities in O&M technology and techniques going forward. And we're really also trying to bring that cross-sector businesses into the industry. We're doing that really focusing on 3 interconnected themes of next generation ops and control, and I'll go into these in a little more detail in a minute. Inspection, maintenance and repair, and O&M decarbonisation. So for next generation ops and control, imagine everything that basically happens from an offshore wind perspective onshore. So everything that happens in terms of planning, logistics, scheduling and control of the wind farm right up until the technicians actually walk out the door. So as far as industry is concerned, what are the major challenges that we've been working with industry on to date? We're looking at minimising unplanned maintenance and repairs impacts, optimising logistics, and trying to balance yield and equipment lifespan. A lot of what next generation ops and control is about is really harnessing the value of the data. So it's very data intensive, and it's bringing a lot of those industry 4.0 techniques to bear to look at the solution in its entirety and look for those gains that can actually make the operation not just more efficient and more productive, but also help the UK supply chain build systems and products to help the whole industry. Also, really focused on data security. As far as the innovator is concerned, those that are looking to get into the industry, there are challenges around understanding what the industry is actually about and trying to find those opportunities to actually break into industry as well. So from the OMCE, we're really focusing on providing the domain and data expertise across data analytics, artificial intelligence, machine learning, digital twins, cybersecurity visualization, hardware in the loop, and also providing those data forums and governance to help people understand what the data actually means and the value that it can bring. So we're focused on scoping, development, testing and demonstration of those capabilities. The vision going forward is to develop an integrated data-driven development, demonstration and test platform at utility scale, and there'll be more on that as we progress. Inspection, maintenance and repair. So if we've talked about everything that's happening onshore, now everything that happens offshore, from the moment the technicians walk out the door to going out, working on site, and then returning safely. So industry challenges, remote asset management and support. So as wind farms get bigger and further away, that's becoming much more of a challenge. Maximizing the availability and yield, of course, and making sure that the inspection of the plant and the equipment is conforming to regulations, but also to satisfy the lean operation of the wind farm. So focused on improving safety, reducing risk, and also introducing robotics and autonomous systems as much as possible, and the interaction with assets and technicians, and understanding that human-machine interface as well. So from industry's perspective is how do we actually introduce those RAS elements and make the whole program, the whole system more efficient, and how do we get our crews to actually work with these assets as well. From the innovator's perspective, it's really focused on getting access to those realistic environments, those assets, and trying to understand the uncertainty around the regulations and the safety case of actually bringing those systems to market. So for the OMCE, we're focused on the piece in the middle there. So as in trying to take the problem owners and the solution providers and bring them together with information, translation support, and access for innovators. The development, we're also offering development, test, demonstration, and certification facilities for robotics and autonomous systems, safety systems, advanced sensors and tools, communications technology, and training systems. And where that's going to go, the vision is that we're looking at developing an offshore demonstration zone for test and evaluation, operational test and evaluation, and also an advanced comms test rig to provide a backbone from shore to wind farm for all of those high communication requirements, devices and technologies. For O&M decarbonisation, so this is across the piece. So looking at decarbonising operations and maintenance from wind to wake. So there are a number of industry challenges regarding this as well, of course. So clean maritime targets, how do we achieve those, or how does industry achieve those by 2050? There's massive cost and risk with transition to low carbon fuels, particularly. How do we integrate these new technologies into the existing ops? And there should really be an opportunity to use offshore wind as a springboard industry for maritime decarbonisation much more broadly, particularly in the UK. Minimising decommissioning costs and waste, so starting to think about the other side of the O&M decarbonisation puzzle as well, so that it's not just focusing on the fuels for maritime or for the vessels and for transport, but really looking at the whole life cycle. How do we minimise those costs at decommission, and how do we demonstrate the circular economy? So it really does require a massive amount of collaboration across the industry, across academia, and across government in order to achieve net zero, certainly by 2050. As far as the innovators are concerned, what does the market want? What does it need? It's also focused on, or very keen to understand investment risk. What does it actually, what's backing a winner actually going to look like as far as O&M decarbonisation is concerned? And also, what's the extent of offshore and onshore infrastructure, particularly when it comes to zero carbon or low carbon fuels, so hydrogen, ammonia, electric refueling, etc. So from the OMCE's perspective, the plan is that we are leveraging existing national development we're focusing on vessel integration, so those alternate fuel supplies and the shore and the operational integration. How do we get it to all work together as a whole system? And decommissioning, recycling, research and development on decommissioning, recycling, zero waste and the circular economy. Right, into the future, really focusing on making an alternate fuel hub, and also focusing on net zero port. They're the main aims going forward as well. So that's really just a very high level introduction to what the OMCE is all about. And I'll hand over to Catherine in just a moment, who will provide a little bit more detail on the agenda for today and also some of the activities that we're doing going forward. But we hope that you really enjoy this today's event, find it very informative, and we certainly hope that we're going to be working with you all a lot more in the future. Thanks very much. Catherine, over to you.
Hi, I'm Catherine York. As Ben said, I manage the Operations and Maintenance Centre of Excellence for ORE Catapult. I've worked in the renewable energy sector for the past 12 years, and particularly the last 8, I've been involved in operations and maintenance of offshore wind from Grimsby. I joined Offshore Renewable Energy Catapult in March, and I'm really excited about the opportunity to accelerate some of the developments and improvements that we can get with the products and services within operations and maintenance. Whether that's from the large-scale projects that you'll see and hear a little bit more about later today, down to the small and very local increasing in collaboration and ideas generation from the people who are actually involved in the tasks and experiencing some of the pain and difficulties of the jobs. Today, we've got a little more detail of the agenda coming up. We're taking the 3 themes that Ben discussed in a bit more detail as our strands throughout the day. In the first session, we'll be looking at things like how we can fast track the energy transition and how we address the challenges of using remote and autonomous systems for dull, dirty, dangerous, demanding, distant and distributed work in that sort of context of offshore wind. Then we'll come back at 1 o'clock. We have a discussion on meeting the challenges of maritime decarbonisation, what fuels, how to deploy them. And at 2:30, then we'll be looking at how we make data-driven decisions from looking at the weather through to the end-of-life strategies we might be implementing for these wind farms. And today is the start of what will be a rolling programme of showcases and exhibitions at the OMCE. We will be deep diving into specific topics, starting off with metocean and alternative fuels, and more to be released as we unveil them. And we plan for these to be engaging, collaborative events to bring together industry, innovators, cross-sector working, academics, bringing the whole host of expertise together so that we can really go into detail and get people to understand what's coming, what could be coming, what projects they could be involved with. So all of this building to accelerating those innovations, reaching the market, whether that's just through introducing so that you understand what's available, get the chance to challenge and question, or actually be involved in developing the upcoming projects. Now we've got a few minutes before the next session starts. So I think at this point we'll take a short break and everybody come back for 10:30 and we'll kick off with inspection, maintenance and repair. Thank you.
Okay, that is at 10:30. I want to do a quick introduction and say hello to everyone that's listening, and a big thank you for joining us today. I want to say a big thank you to Catherine and Ben for the introduction, and I've also been told that we're on social media today on #Catapult Grimsby. So if I can, I'd like to push that. I'm Dan Sumner. I'm a project development manager here at ORE Catapult. I tend to have a focus on robotic systems, RAS in general, but I don't want to talk too much about myself today, as we've got a great set of speakers, panelists, and a setup for a Q&A later on. I'm going to give quite a brief introduction to this morning's topic, outlining a high-level overview of the trends that we're seeing in offshore wind today and how those are going to lead on to future challenges for O&M. Then there's going to be 3 presentations from our guest speakers, followed by a combined Q&A session at the end. Now, for that Q&A session, I'm really looking for some audience participation today. I'm actively looking for some great questions that we can pick for the panel for later on. So please, these things work best when you all get involved. So lots of questions, please. Okay, let's kick it off. So it's well known that offshore wind is continuing its unprecedented growth across Europe and indeed the world. We've seen the levelized cost of energy decrease faster than originally forecasted. And that's a fantastic, brilliant success story. One that is primarily attributed to a couple of different factors. So the development of larger capacity turbines, improving the economics of installation and operations, per megawatt hour. We've also seen the growth of farm capacity as a whole. Again, improving the economics, such as the effectiveness of transmission network. Our experience has grown with the development of each new farm, enabling further industry optimization. And also through the development of new technologies, constantly changing, constantly improving over time, maximizing the production for every pound or dollar or euro spent. Now, while this reduced LCOE is fantastic, it does present new challenges for the industry as we follow this optimized route. Lost production becomes more prominent with the use of large turbines. So shutting down for a day of work, it now costs more with a larger turbine than it would have done with a smaller one. OpEx margins continue to be squeezed in a race to the bottom, meaning that we now have to do the same or more with effectively less. The size, accessibility, and environment is also becoming more challenging as we move further away from shore into less accessible environments. So if we look at this graph on the right-hand side, you can see a plot of the average turbine capacity over the last 2 decades, which those are the bars, showing growth of turbines over time. So we can see a small but notable increase in the number of turbines within a site as well. That's the blue line, showing the growth of farm capacities. So, but with both of these pieces of information, what does that mean for O&M? Within the North Sea, we currently have commissioned about 16 gigawatts worth of wind capacity, made up of around 3,500 turbines. By 2035, we might see as much as 136 gigawatt worth of wind capacity. That's about 8 times the current amount in the North Sea, but only made up of 7,500 turbines. So you can see the trends that we were talking about a minute ago. A trend which we're seeing in the North Sea is the increasing distance of farms from shore as well. So the plot on the right there shows the average distance of farms from shore in the North Sea over a number of years, slowly increasing. And the motivation behind this is down to, again, a number of factors, including space for leasing, what's the wind resource like, what's the technology advancements for unlocking those new sites, decarbonisation of maybe other marine sectors. So we can see a clear trend of average distances increasing above that 40 to 50 meter depth, which is considered deep water for offshore wind. So looking at similar things, but maybe on a map, everyone loves a good map. Let's look at the offshore wind industry currently in the North Sea. This map shows currently commissioned wind farms. So each circle is a wind farm, and the size of the circle is scaled based on the capacity of that farm. The colors represent the foundation types on which the turbines sit. So quite easily, you can see that fixed foundations are by far the norm, with monopiles making up the majority. We can also see that all our assets are relatively close to shore, with much of the North Sea still available. So real quick recap, what do we know so far for offshore wind in the North Sea? We're moving further away from shore. Met ocean conditions on average are going to be more severe, maybe higher wind speeds, greater wave heights. We know that water depths are increasing beyond the 50 to 60 meter range considered deep water. We know seabed sediments are becoming more variable, and we know there's an increased proximity to other users and assets. So what's the impact of these changes? And how does that affect O&M? Here's just a handful of challenges that I've highlighted further from shore. So as we get further out from shore, how does your O&M strategy change? How will this impact logistics, the importance of connectivity, comms? As the water depths increase, how does that impact your cable lay route, or what impact does this have on installation vessels? As wind speeds get get increased and as larger waves start to hit, are your robotics ruggedized to this harsh environment? And as you start to work with other infrastructure, how does that physically work in simultaneous operations, as well as things working with partners in the aviation? So the question today, or the question for the panelists today, is, are robotics the answer? So robotics and autonomous systems are forecasted to reduce cost and to improve safety. But from experience with the Catapult, there are some common barriers to entry. Is the technology, is it ruggedized? Does the performance good enough? Is survivability there? What about the economic case in terms of cost or time? What about regulatory and process? So does it meet the current legislation or standards even for the future? And the wider, more open societal changes. Do we trust these robotics? Is the confidence there through a number of different stakeholders? So hopefully, to touch on some of these interesting questions, we've got a great panel for you today and some great presentations. So we have Professor David Lane, Hub Director at ORCA. We've got Rebecca Allison, who's an Asset Integrity Centre Manager at the Oil and Gas Technology Centre. And we've got David McKinnon, a Technology Advisor through the TLB. So with no further ado, I would like to present David Lane. Do you mind having a chat, David? Thank you.
Hi, thank you, Dan. Wonderful. I can't start my video, so I can't say hello to everybody in person. Maybe somebody could do that for me. Okay, here we go. Right, hopefully you can all see that. Somebody give me a thumbs up. Dan, can you see that? Just give me a thumbs up, thanks, great. So let's start this slideshow, play from start, here we go. Good, okay, so I'm gonna go for sort of 15 minutes or so. Thank you for the introduction, Dan. My name's David Lane. I'm the director of the Edinburgh Centre for Robotics and also a thing called ORCA Hub I'm going to talk about today. Centre for Robotics in Edinburgh is a joint venture between Edinburgh University and Heriot-Watt. We're about 30 academics, 120 million of activity, 120 PhD students and postdocs. So we're a big engine of research and innovation in robotics and AI, not just in offshore energy, but also in other sectors like construction and nuclear and agriculture and medicine and blah, blah, blah. So we're quite a big machine. I wanted to just say a little bit about who we are and how we fit into, it was great to hear Ben and Catherine's comments and the new facilities at Grimsby and how that fits with ORE. How do we fit with all that in the work that we do? And Dan mentioned the idea of, or the notion of innovation. How do we get ideas and research from university world into, in this case, offshore wind and O&M. We have a thing in the Centre for Robotics, a new facility called the National Robotarium. This is a slightly old slide now. We've had a change of prime minister since this was done 2 years ago. But it's a brand new building. It's a sort of living lab facility currently in the process of being built. It'll be commissioned either late next year or early the following year when the building finishes. But what it's going to do is allow us to do this, which is how we innovate in the way that we bring robotics and AI and autonomous systems from crazy ideas in university and core research up to higher levels of TRL into established practice and products and services. We simulate, we then emulate with hardware in the loop in particular. We use living labs as demonstration environments, and indeed the National Robotarium is part of the way that we do that. And then we move to site labs to try things out. So we're progressively increasing the technology readiness level as we go through that sequence. And obviously, whereas we have the ability to simulate, emulate, and do living labs in our facilities in Edinburgh, we need to work with partners such as the new facility at Grimsby and ORE and others in Rosyth and other places in order to give us access to site labs where we can actually try stuff out and go and do it. And a key enabler in this, and it was great to hear Ben mention this in his introductory comments, is the use of digital twins. And for me, this is one of the huge growth areas that this industry and other industries does need to get their head around in order that we can do the how, not just the what, of some of the visions that Ben was talking about in his presentation, and indeed Dan was saying in his. And I'm not going to talk about this too much today here, but the future of digital twins is all about not just individual twins, but connecting them. And there's a whole lot of work that we're involved with, which is about establishing the data infrastructure that's going to provide us with the core means to do the kind of translation that was talking about in the previous slides. There's a twinternet or worldwide twin out there waiting for us, much like the World Wide Web, which will be equally transformational in the way that we move things forward. I don't have time to talk about the detail of it here. I am doing something this afternoon on a Subsea UK event where I will say a little bit more about that, but that competes with this, so I won't say any more here. What Dan asked me to talk about, and I will in my time, is more about this thing called ORE Hub, which is a hub which involves all the universities you can see across the bottom there. So it's ourselves at Heriot-Watt in Edinburgh, but also Liverpool, Imperial College, and University of Oxford. It's funded by the Industrial Strategy Challenge Fund. It's part of the 96 million that was made available for Robotics for a Safer World through Innovate UK and EPSRC 3 years ago. And its whole point is to do use-inspired research, but also to translate that into products and services and to start that process. So exactly what we're about in the National Robotarium and the Centre for Robotics. And we're in the business of looking at how do we re-envisage and reinvent how some of the asset integrity management is done in offshore oil and gas, but also in offshore renewables. And the circle you see in the middle will be familiar with you, the kind of thing that that people do. And in a nutshell, we're more interested in how do we use data and how do we use robots from that data to generate that data, but also from that data in order to do inspection and to do repair and eventually to do maintenance. And what we're looking to do is deal with the situation on the right of this slide where these two old guys are having a conversation about what their day is going to be like and how long is it before I retire. So there's an aging workforce issue as well as issues of safety and cost of having people offshore. Lots of industry members, some more active than others. You'll see people here, not just from oil and gas, but also some renewable energy people, so EDF in there, for example. And we're looking to bring more people from the renewable energy industry into the work that we're doing in the hub. This tries to explain how we think we work in the hub through the range of technology readiness levels, going from 0 at the top to 9 at the bottom. On the left-hand side, that's the long way up, I know. We have this notion of spiral innovation. This is a 2D projection of a 3D spiral. It's called more like a chirp. And we go from discovery and research through innovation to commercialization. And we have our core research themes. We have support from the Engineering and Physical Sciences Research Council that supports the researchers, but our partners funding support helps us to go from the journey from the early stage research and TRL 3-4, which is what we do in the lab and in the universities, through to 6, 7, 8, which is what takes us out into commercial world. And so we use the funding support of our partners in order to take the results of the research, and we have a big emphasis and turn it into products and services. And so we have a big emphasis on thinking not just about the science that we do, but also the use cases for that science and the capabilities that are required in order to realize those use cases. So success for us is journal papers, it's good applied science, use-inspired science, but it's also how good are we at turning these into commercial products and services. So what I'm going to do today is just talk a little bit in the time I have about what's some of the core science work that we're addressing, and then talk as much as I can about some of the applications that we're trying to take them to. I'm a bit limited in what I can say there because there are some sort of commercial competitive pressures which get in the way, unfortunately. And then a call to action at the end saying, you know, we'd love to work with more people from the offshore renewable energy supply chains in order to help us get this right and make the innovation pipeline from the fantastic science base we have in the UK through to products and services that support our industry. So 4 pillars of activity going on. There's a bunch of work on mapping, surveying and inspecting. Some work on, we call it planning, control and manipulation. How do you move the robots around? Some work on the human-robot interaction. How do I know what the robot's doing Is it autonomous? Is it semi-autonomous? What the implications for that with how, autonomy is all about the operator. And then finally, some work on certification. Certification of the robot primarily for us, but also its certification of ultimately the asset, because that's the thing that you want to do. And self-certification, I think, is something that's an interesting topic, not yet properly explored. Can we build assets that self-certify their safety? Ooh, that's an interesting idea. Certainly we could try to do that with robots. I haven't got enough time to really give all this work justice, but I can at least give you some flavors of the kind of things we get involved with. So, for sensing and perception, we really care about reconstructing 3D shape from 2D images, from motion, from inferring our own motion from how we see, perceive objects moving in the environment, so-called SLAM, and then building semantic understanding from that. If a robot's going to plan what it's going to do, it has to understand what it's seeing in a scene through its various sensors, and then be able to turn that into actions that it's going to carry out to achieve its mission. So, various examples of the kind of data structures that we deal with. We deal with sonar, we deal with video. We also deal with other forms of NDT sensors, EMAP, I'll talk about that again in a minute. We do 3D reconstruction. We build semantic maps of that. Those are the sort of semantic descriptions. Ontologies is the word people use. And these are all components of digital twins. When people say to you, what is a digital twin? It's not just the physical representation of the world and the physics of the world. It's also about some of the semantics of what the world is, and indeed the processes that people are involved in those worlds in order to carry out the tasks and the work they do. So digital twins is actually quite a more complicated idea than just physics and geometry. And so I think I alluded to, we do, the core science we do is deep learning and visual SLAM, simultaneous localization and mapping. So we're able to infer motion, because some of these, the marine environment is GPS denied when you're underwater. So you have to have ways of either having, acoustic navigation, or you try and navigate yourself by what you can see. And there's a load of applications, and there's some use cases which I haven't got time to talk about here about what we do. So a strong capability in doing this. You'll recognize some of it from self-driving cars. The community who do that work are similarly engaged. The difference is we're doing it with drones, we're doing it on the asset, and we're also doing it underwater. And the underwater community have been busy doing this for more than 30 years. So we've been doing it a lot longer than the self-driving car community. We're interested also in sensor networks and the robotics Internet of Things. We care about, particularly for subsea assets, which in oil and gas more than in renewables, I think, are important. We care about being able to network nodes, being able to communicate, being able to, especially when communication distances are limited, being able to relay information from one node to another, from one vehicle to another. So putting together effectively, you can't use TCP/IP and the standard internet protocols that we use in air for a bunch of reasons about packets and retransmitting packets. So how do we build these ad hoc networks to do distributed sensing, and indeed use that for navigation? So using acoustics, obviously acoustic modems underwater. So big piece of work going on there with various of our partners. We care about some sensor development, and not just about the sensor development, but also about, if I can shut this guy up, I'm making a noise, that makes him quiet. We care not only about the sensor development, but also about the sensor delivery. So drones are increasingly used for inspection, but the sort of boundary of where a drone is going to go next is also about how do drones intervene and do physical tasks on assets offshore. So we're thinking about that. This is an EMAT sensor. I won't go into the detail. It's using, it's generating ultrasonic waves for doing inspection and crack detection in welds. And we've got some small portable sensors that we're able to deploy from drones, for example. When it comes to planning and manipulation, again, I haven't got time to talk about all the things we're doing here, but this is one example of the kind of technology that we're involved with. Bottom left, there we are deploying the EMAP sensor, this time from a mobile robot. The videos you're seeing on the right-hand side are showing some of the examples of how we're planning the motions of mobile robots so that they can deploy sensors while they're on the move. So the thing that's novel and inventive here from the science point of view anyway, is that if you think about most warehousing applications, robots tend to stop and then do a manipulation or do a deployment. Here what we're doing is showing the robot doesn't stop, the robot keeps going. So the way that we plan the motion of the robot in the top diagram is actually more difficult than you know, but it has advantages about how quickly you can deploy the sensors in this case. And the sensor we're deploying is a thing called a limpet sensor, which is one of an example of a class of sensors that you may want to deploy in order to give you long-term in situ measurements of other things from the asset for its integrity. And the one at the bottom is just showing off. It's called chicken head, and it's just showing that we can stabilize the tip of the manipulator in this case, whilst moving the body of the high number of degrees of freedom of the body. We're also involved in the platforms. Obviously, you saw wheeled platforms in the previous example. Here we're looking at using quadrupeds. Some of the environments that we get into on offshore structures and indeed elsewhere are not really amenable to using wheeled robots. So quadrupeds are the future, we think. And there's large numbers of degrees of freedom, lots of opportunity, but lots of issues as well. So you'll see here, this one, you know, we care about what happens if you're going over uneven terrain, trying to go up ladders, and robots fall over. So we use machine learning in this, and this is an example of where we cross the digital to physical divide. We do a lot of the machine learning about how can the robot learn to stand up when it falls over in the digital world, and having made that work, then we move to the physical world and the journey that I talked about earlier about harder in the loop, and then living labs. You know, we work with the real robot to do that. In fact, the test that we did here, the living lab environment, was at the Fire College, where we were, you know, it was a realistic environment we could set up. And some of the things top left here about how we can use the robot to physically intervene in the environment is something beyond what a mobile robot can do if you don't have manipulators. So we're researching this, understanding the science, understanding how to use it. On the human-robot interaction side, how do we know what the robot's intending to do if it has any kind of autonomy, either fully autonomous or a shared autonomy operation? So we're working on generations of interaction systems that are explainable AI, where the robot can explain what it's doing, think about it as WhatsApp with your robot. And here's an example of a system called Miriam. It's a kind of personal assistant. You'll see there's a virtual world here. It's a graphical world. We're modeling the drones going off to inspect a fire on an offshore structure. And in the chat window, you can see in the middle-ish, you can see some of the dialogue that's going on between the operator and the system to ask what's going on, where are the robots, what happens next, how long have we got before we hit a critical point. So it's not just about the robot, it's also about the state of the asset and the state of the situation. And we think this is an important technology for, as we have more sophistication in the robots that we take offshore, this kind of ability to explain, ability to interact is important. And beyond WhatsApp, or beyond, sorry, not WhatsApp, beyond Alexa and Google Home or any of these chat interfaces you have to systems at home, it's not just a one-shot exchange. It's not just I ask a question, you get a reply, and then the next question is something completely different. There's an element of narrative in this, so that each exchange between the person and the system builds on the other, and you develop further from that. And that's more complicated than you know. As soon as you get into that kind of narrative and discourse, it's quite complicated how we decide what to say next based on what we've already said. It involves a shared understanding of the state of the world and the domain that we're having dialogue about. So we're trying to develop that and take it offshore, and then also using novel kinds of interface. So the chat doesn't just have to be through a WhatsApp kind of interface. We can use talking heads such as, this is called Fur Hat, that hasn't got his hat on today. And I've turned the sound down because it's a bit annoying on a talk like this, but you get a reply back from the system telling you what's going on. So we think this is, the sort of kind of research that this is part of the systems that we see for the future. And I apologize for the noise in the background. I've got a dog and visitors in the house, such is life during the pandemic. Finally, I want to talk a little bit about robot and asset self-certification and the kind of work we're doing there. We are interested in the robots being able to certify that they are safe, but also how do we go about certifying that the the asset is safe. And this takes us into the domain of things like condition monitoring, prognostics. Digital twins are really important to this. The digital twin should be running in parallel with the real asset. And actually, if you're running machine learning on the digital twin and the asset, then that gives you the essence. You can understand when something diverges from what the twin is saying and what the asset is providing you with real-time data. Then that's part of your prognostic and your condition monitoring strategy. So digital twins are very important for that, and we're trying to develop some of the machine learning technology around that. Here's a simple example, actually, on one of the robots, and it's not just about the recognizing that you've got a problem. It's also about what you do about it to keep everything safe in the short term. So here's the three pictures videos left to right. It's an underwater robot. The one on the left is successfully traveling from one point to another. The one in the middle, we've deliberately failed one of the thrusters, so it can't hold the heading anymore. And when you try and drive in a straight line, it just spins off at a funny angle like that, which isn't safe behavior. The kind of corrective action we can take here is that even with a damaged thruster, we can still adapt the thrust vector that the robot carries out. So in the right-hand one called automatic recovery, you can see the robot moves from the start point, ends up at the desired target. It's just not pointing in the right direction, which is a much safer behavior than the one in the middle where it's sort of spinning off out of control. So this is the kind of thing that we're thinking about with digital twins and control systems at the heart of that. We think hard with our industrial partners about how to take these capabilities that we generate from the science base and turn them into use cases that can be useful to companies. And so at the beginning, I showed the spiral innovation model that we use. So again, here's some examples of some of the use cases that we've worked on. We've got a cartoonist to try and map them. They're a bit too complicated for the time I have here. So subsea inspection and survey, autonomous inspection, maintenance and repair, unmanned autonomous decommissioning. These are some of the things that we think about. And some of the demonstrations that we've done over the years, this is one, the first step we did in July 2018. We went up to the Underwater Centre in Fort William, went out of business, but now back again just. So this has been a great test space for us over the piece, particularly for doing marine work. And you can see some of the things, the capabilities that we've demonstrated there with our industrial partners. We did a second set of demonstrations at the Fire College, which is in Middle England. I can't remember the name of the place. Where the fire brigade normally go to help practice putting out fires. And that was great for us for practicing some of the terrestrial robot applications and drone applications in particular. And then latterly, the last set we did before the pandemic and the lockdown was we went to Blyth, and Dan was there and involved in all that. And we did a series of demonstrations there. I've got a little bit of video here, which if I can get it to go, can just show some of the kinds of things that we were doing. Again, I haven't got time to go through it. Here we're showing some examples of robots going off to do inspection. Here's everybody getting a brief. Here's Husky. Yeah, so here the Husky robot's going off. It's working completely autonomously in this case. It's mapped its environment, and we're going on to the ROV piece next. What was good about this is that we deliberately failed some of the computers on the robot. And we were able to reconfigure the robot on the fly as part of the self-certification. So the robot recertified itself and reconfigured itself in its computing on the fly in order to deal with those kind of failures. We did a lot of marine work there. The visibility was terrible. I just wanted to show one thing, and I'll be careful what I show here, the drone. Here we go. So here's an example of the sort of drone technology done by the team, Mirko Kovac's team from the Imperial College in London. And this drone is carrying, imagine it's carrying a sensor. It's about to fly into this panel on the left-hand side. And imagine the panel on the left is the blade of a wind turbine, right? And what we're going to do is inspect or indeed do some maintenance on the blade of that wind turbine. So what the drone is going to do, I'm going to speed it up a little bit here, is connect itself. And then the cool bit is it's using tensile perching, so-called. So it's bio-inspired from how spiders and other animals work in nature. And the drone lowers itself back down onto in this case, imagine it was a blade. And then once it's got there, it could move around on the blade, and indeed it could do some inspection. This is a very, very early stage, crazy idea. demonstration of the control systems and the principles. Clearly, you have to robustify that a lot to get it to something that you can take offshore. But there's some very novel thinking here going on about how do we take capabilities of drones in this case and move them to a place where they can do physical work around structures, which is a desirable thing for doing the maintenance part and the repair part, having done the inspection part, which we do well at the moment. Right, what's happened here? I think I'm looking at the wrong screen now. Here we go. I'm not sure what you guys are looking at. Okay. Probably getting, I'm not sure if you're seeing the whole of my screen here. How do I get this to go back? Are you still seeing the screen, or what are you seeing? I'm not sure. I'm seeing something different here. Okay, let's move on to the next slide. Yeah, okay. So after 24 months, we've had 11 industry translations, an extra added value of 2 million, and quite a large pipeline of research going forward, which some of which are spin-outs like adabotics.com coming from the hub, and I think there's something going on with the slideshow here, so let's try and do, let's go up here to do it, play from the current slide, there we go. Right, so let's go back the way, that's better. All right. Right, sorry for the gremlins there, everybody, this is PowerPoint funny. I'm not able to talk too much about the detail of those because there's some level of commercial in confidence, but suffice to say that there are companies mainly from the supply chain and from oil and gas who are taking this up and turning it into capabilities and helping us take it out to higher TRLs, around 6, 7, something like that, and then ultimately taking it offshore. So the call to action here is that we're able to work today, tomorrow, in the future in the way we work in the National Robotharium. TRL 7 to 9, we're interested in single and multi-part commercialization projects from this. For tomorrow, TRL 4 to 6, we're interested in user-led development projects. And the future, we're interested in people getting involved in sponsoring PhD students in our Centre for Doctoral Training that we have, and plenty of EPSRC-funded PhD students interested to work on projects like this. Further details, contact me by all means, but the people that should really also get in touch with Lindsay Wilson, who's the ORE Hub manager, and David Wavell, ORE Hub business development. And at that point, I'm going to say thank you very much and apologies if I've slightly overrun Dan. I hope that's okay. Thank you. Dan, back to you.
Yes, thank you very much. Could you please enable my video back in, please, Vicky? Or in fact, it doesn't matter. No one needs to see my face. We can just carry on with audio. Okay, so thank you very much, David. That was brilliant. ORE Catapult are working really quite closely with ORE. Watch this space for a little bit more on that. But I would emphasize it's very much worth getting it in touch. There's some really impressive technical expertise there. And I'm sure everyone on the call can relate to technical gremlins and the challenges of working from home. Personally, I get that quite a lot. So next up, we have Rebecca Allison from the OGTC. So please take it away, Rebecca.
Thank you, Dan, and hopefully here I will share my screen, which is always a bit of a challenge for myself. So hopefully we can now see my screen. So thank you everybody for attending today's session. As always, David, thank you for giving me a new word, Twinternet. I will now have to start thinking about that in more detail. Every time I meet with you, I come up with a new word, so thank you. So, now, why is the Oil and Gas Technology Centre here talking to the renewable sector? A couple of things. This is all part of the energy transition. So, OGTC and the oil and gas industry are very much around a transitional period of how do we look into the future of some of our obligations. And, if anybody's been following ourselves or the ORE, we have recently announced a partnership around the Energy Transition Alliance, where the two sectors will work together to come up with some of our goals that we've all set ourselves from not only the industry's perspective, but some of the government challenges as well. So certainly from our perspective, from the oil and gas industry, we are very much aligned with the future basin and what it looks like, and what does the energy demands look like. So, we are working on some significant challenges around decarbonising operations, which was touched upon earlier this morning. The integrated energy piece, looking at alternative fuel sources, as well as the hydrocarbon side of it. And then obviously, how does the oil and gas industry, as well as the other sectors, contribute to the net zero aims that the government targets have been put in place. So we are very relevant. And some of the discussions that we have been having are very much about the fact that oil and gas and renewables have the same technical challenges when it comes to operations, maintenance, or inspection activities. And I do sometimes talk to some of my integrity engineers saying, oh, I don't know how long I've got in the future, for oil and gas, maybe I need to go and do something else. I want to work in renewables. But when you talk about ops and maintenance, it's the same challenge. It's asset management. So whether it's a floating offshore wind structure to a fixed monopile or to an oil and gas platform, they all have the same challenges, that we need to maintain them, inspect them, and make sure they're safe to operate. And at the end of their life, decommission them in a responsible and safe way. So to me, it doesn't really matter what background or what sector you're from, the challenge is always the same. OGTC has the same goals that we've always done. We have been on the go for the last 4 years or so, funded by UK and Scottish governments, and as part of the Aberdeen City deal to fund the technology acceleration of the oil and gas industry. Part of that remit was around the unlocking the potential of the North Sea. So we are and continue to support the Mayor UK initiatives to maximise recovery, but that's with the lens of in a more responsible and low carbon future. So we are still looking at technologies and initiatives around that. We're also, and have always been at the core of, it's anchoring the supply chain, growing companies within the North East region or in the UK sector to increase our skill base within the UK and develop that further. And then the other part, which we do a lot of, is really inspiring and working with the next generation, as well as some of the other different stakeholders from different parts of sectors or industries to say, how does the net zero future look for the oil and gas industry as well as the energy sector. So our goals haven't changed. They have just now got a different focus from maybe when we started our messaging 4 years ago. One of the things that people do talk about, oil and gas, is it really relevant anymore? What is the future of the North Sea, especially from the supply chain point of view? We do see people saying, oh, I want to now start focus on renewables. I want to move away from some of the oil and gas type initiatives. I don't really want to, especially in startup companies. We see a lot of startup companies feeling that they can't get investment in the oil and gas area. And one of the things we do say, the future is a blended approach. For the supply chain, across the different energy demands, oil and gas will still be there in 2050. Okay, it won't be so much a demand, but there will still be a large service provision required, especially around some of the decommissioning of the older assets or the repurposing of assets for whether it's for hydrogen production to carbon capture. And then obviously we've got into the renewable side as well, as those fields develop that Dan had alluded to, that the increased activity will also bring opportunities for the supply chain to diversify and cover all different angles. So we do see the industry as a whole growing significantly over the next 20 to 30 years. So from our perspective, we start looking at it at 3 different lenses. And again, it's kind of been touched upon with David's talk about, what we're doing today and what's the future like tomorrow. And we always have been working around this whole fix today. So there's a lot of challenges that we need to really get after at the moment, which is around data management, digital twinning technology, the inspection activities that we all know, and how we can actually use different technologies to really drive down some of the operating costs that we currently have, not only in the oil and gas sector, but certainly within all of the different energy sector, because ultimately if we can drive down the costs, then the more effective some of our inspection techniques will be. But then when you're working on stuff fixed today, you always have to look at the future horizon. And, we have some significant targets that we all have to meet within the next few years. So when we start making decisions of future investments and activities, especially around the robotics and automated systems, we actually now have to start looking at how do we unlock that potential? What do we need to invest in to actually help drive that potential forward. So, you know, the remote operations, that is a challenging area to work and move into, especially if you're looking at old infrastructure. Can we actually make the operations remotely operated? How do we use robotics on some infrastructure that was never designed for? And then when do we start looking at new materials? We look at alternative materials that we bring in. Do we know how to maintain them? Do we know how to inspect them? So again, some of the technologies we're looking at today, we have to start thinking about how do they feature in the potential, and then in the transform tomorrow, what does 2050 look like? You know, if we are doing a energy mix, we're producing hydrogen, or we're using carbon capture and storage, you know, how can we reuse our infrastructure? What needs to be done in that piece? And if we are going truly automated and going for unmanned facilities, what does that actually look like, and what's the steps we need to take there? And so some of the lenses we look at are very much around the sort of the 10-year cycles of what do we need to do today to start thinking about the 2030, the 2040, the 2050. Because without that investment and the forefront for some of the research that's coming out of ORCA and some of the other work that's been done in research, we need to be able to translate that into some workable product solutions. So where does that all fit in today? Because we've talked about robotics and we've talked about, you know, automated systems and digital twins. And one of the things I kind of keep thinking and going back to, we've got a bit of a disconnect within our industry, and I'm not quite sure how much disconnect there is in maybe the renewables as well. But certainly, I recently started looking at inspection integrity reporting, because it has been a big topic. Not so much, you know, we do talk about the robotics and the automation side, but ultimately, what do we want the robots to do? Well, we need them to actually ascertain what the asset condition is. So when I started looking at this from an reporting point of view, you know, very familiar scenes, we send people off to do some inspection, whether it's on a fixed jacket or hanging off ropes or using iPads to put the data into, all very familiar scenes. And that's still going on today. You know, if you go to any offshore asset, we still have people doing this type of work on a daily basis. But we talk about, well, we're automated, we've got digital, we're all very familiar, we pick up our phones at any second, you know, to find, you know, with online banking, to, you know, booking our cars in for MOTs, you know, we get sent, especially since the pandemic, we get sent a lot more digital information. You know, I haven't signed a bit of paper for a long time now, due to the pandemic, etc. But our offshore industry is not quite the same. So when we looked at it, we went back to the future almost, 2009. This is how we did inspection and integrity reporting in the oil and gas industry. We went out, we had a bit of paper that was electronically filled in on a desktop computer and was hard copy signed. So somebody actually printed this out, went and did the inspection, typed it up, and then hard copy signed it. 2009, that was. This is a live report from 2009. One of our industry partners kindly gave us this. So 10 years, 11 years, we've gone digital now. We've got iPads, we do all this online, we send information up to the cloud and we take it back and we use artificial intelligence to determine what our condition is. Oh, 2019, same asset, same vessel that was inspected. We have gone digital because we've got a digital signature. Different contractor, so it's not the technology provider, you know, it wasn't service contractor said, well, I've done it this way, and somebody else has come along and said, well, we haven't progressed, because it was two different inspection companies doing it exactly the same way. So this is where I kind of go on about this whole disconnect. You know, we talk about putting robots out to, you know, live on the jackets, crawl up and down blades, do inspection, send information back. But in reality, we're not quite there yet. And if we're still in this kind of phase where we're still putting in almost paper reports, okay, they're electronic paper reports, but there's still somebody filling in boxes and doing some inspection activity, how, you know, what will the next 10 years look like? Do we have enough support and appetite to move to the next 10 years of going fully automated? Because I kind of see this as a bit of a chasm that we need to jump over. But it's not all doom. We do have some companies, and we actually have been working with two companies in this space, a company called JDI, who have been looking at digital twinning, which is why I'm now interested in Twinternet, but using digital twinning in a slightly different way, because there's always a different interpretation of what do we mean by digital twinning. JDI are a small company based in Aberdeen. They are a software company, so they're not an inspection company. They do have inspection capability within their company. They've brought in expertise of subject matter experts, but certainly what they're doing is using laser scanning technology to be able to start assessing condition from the scan data. So what they're doing is they're effectively going out doing multiple scans. That could be, at the moment they're prototyping, so it's just going out with a person, but ultimately it could be adopted onto any robotic solution, going out using the data and then being able to ascertain the asset condition from the data, which means we don't need to have the reports that we've just showcased. So they're doing that at the moment. They're in trials with a couple of the offshore industry partners that we're working with, and ultimately this is they're able to determine fabric maintenance condition, but also remaining wall thickness and actual condition. So they're away to embark on another phase of the project to take it a step further as well, to do it a lot more automated, because there's still a bit of manual intervention involved in stitching some of the scan data together. We're also working with another software company, a company called Imrand, and they're looking at it from a slightly different aspect. Rather than digital twinning, they're using the inspection data that they're gathering. So the huge amounts of information that's being gathered, and what they're trying to do is spot trends. So they've been using it for more legacy data. So again, a lot of our assets have lots and lots of sensor data readings, whether it's wall thickness readings to online sensor monitoring activities. And what they're using is some automated and artificial intelligence to spot trends that we would normally not be able to spot as a human being. So again, their system called ADA is actually now in the market, completed, and they're doing very well successfully from that point of view. But what they're doing is the next step is really then to start looking at where are the trends, and then being able to hotspot that onto the digital twin. So these digital twins are live, they're interactive, and what they're doing is they're also taking past historical data but overlaying it with data that's live. So using process data, chemical data, internal erosion monitoring data. So again, very oil and gas specific to a pressure system, but this type of technology can be translated into different scenarios. So this is ultimately giving you a quick snapshot in live environment of your threats and areas of concern to focus your integrity and inspection activities. And let's say they will be able to then start trending and showing areas of bigger concern, so you know where to do some intervention. So using the data analytics type technology and the inspection reporting capabilities and moving that into the robotics piece, then you can see it all coming together. But to me, does need a lot more work to be done, you know, and David has alluded to some of the work that ORE have been doing from the sensoring and the robotic systems. But I think there's also a bit that we need to do as end users to start thinking about what is it that we want these systems to do, and are we willing to accept that these robotic and automated systems will actually give us the information we want and we use it effectively. Because there is a piece around the human factor side of this of, are we comfortable with gathering the data like this? Are we, as our service providers, happy and comfortable with the information that's being presented, and can they give the reassurance and the acceptance that when the report's produced, that they're comfortable to say that we can sign off on this, that this asset is safe. And that's some of the challenges we are seeing from some of the other side of this sort of service chain, where we're not 100% sure if these systems are a direct replacement for a human being, or actually are we comfortable that the competency is there, that what we are getting is the right information. So again, let's say there are some challenges around the whole human factor side of acceptance of an automated system taking over some of the systems that we've done manually up to date. And whether that's, we're more accepting around the drone technology. I think there's just a bit more nervousness around the wheeled and quadruped or land-based type robots. But then we've been doing it for subsea for a long time because we didn't have an option. You know, we've been sending ROVs into the water and doing our inspection for a long, long time, and we just accept that that's how we do it. We're kind of okay with drones by doing visuals, drones making contact and doing ultrasonic or doing an inspection from that side. We're kind of a little bit more nervous. But when we start talking about land-based robots, we're kind of go, oh, I don't know about that. So again, how do we change that mindset, and will that just come naturally as we prove and do our demonstrations? So again, just really touching back to where we started, what does the future look like? You know, why does oil and gas need to come and talk to the renewables and say, well, you know, this is what our basin looks like at the moment. You know, we've got fixed jackets, we've got some floating structures, and there's some wind turbines kicking around the coastal areas, as Dan had pointed out earlier. But then when you look at it from the 2050 perspective, we're going to have a busy North Sea. All of this features into the stuff we've been talking about today. Reducing our costs, being more efficient, introducing new technologies to really help manage these assets and for the long term with the low carbon future. You know, if we can reduce our emissions, go carbon neutral, be able to do this cost effectively, then this is what the future of the basin could look like. So I'm going to share my last sort of slide with you on one of my quotes that I like to use, certainly around, this is from Back to the Future, Doc Brown. And it's very much like we have to stop seeing integrity or inspection management as an oil and gas problem or a renewables problem. We actually need to start looking at it as an engineering problem that can be solved. Because actually, if we put our minds to it as engineers, we can do anything. You know, we can put people on the moon. So coming up with the smart vision of the future of how we manage assets in the North Sea, it's probably not that difficult. We just have to go for it and actually think about it a bit more. And robotics plays a key part into that, but we actually have to embrace it rather than kind of sort of saying, yeah, it's there, it's on the periphery, we'll get to it. You know, we are keen to do it, but we're a bit nervous. I think we just have to embrace it and go for it because, let's say, anything is possible. So thank you for your time today. And I'm sure we can answer some questions and have a bit of a panel discussion after our next speaker finishes up with us. So back to you, Dan.
Thank you, Rebecca. That was great. Anyone knows me also knows I'm also very fond of a funky Zoom or Teams background. Big fan of that. And I want to highlight the Energy Transition Alliance. This is a really important initiative for ORE Catapult over the coming months and years ahead due to all those shared challenges that you mentioned. And thank you for highlighting those validation barriers and challenges involved, especially the social ones. I think the ones that don't always get the mention when you come and see and listen to and take part in these calls. And like I said, I'd like to highlight the Q&A at the end. If you've written questions already, we've not forgotten about you. They will be gotten to. So please, this is your chance to speak to these guys. Please get involved. Next up, we have
I will just have to share, the background is actually a wall in my house. That's how dedicated I am to integrity management. I have a wall with corrosion in my house.
That's very impressive. Okay, next up is Dave McKinnon from the TLB. Thank you.
Okay, so hopefully you can hear me and hopefully you can see the first slide. So I'm here to talk about ALTER as a programme, and it's part of an Energy Transition Fund submission. I am representing the TLB, the Technology Leadership Board. I'm sure most of you probably haven't heard of the TLB, but the TLB is, or it aims to be the single voice of the UK continental shelf with respect to technology in oil and gas, and is part of the MER, Maximising Economic Recovery strategy that's legally put down through the Oil and Gas Authority, and the TLB is co-chaired between the authority and industry. So effectively it's an industry board, and we're submitting the ALTER programme in conjunction with OGTC and the Offshore Renewable Energy Catapult. So First of all, to change from PowerPoint, I'm going to show a video. And this video is really to put a little bit more context around the industrial side of things from a robots perspective, but it also draws in the organisation so far. So this programme was done in conjunction with OGTC, but on a spin-off of that, we've now been working quite heavily with ORCA on some of the elements that David alluded to. So hopefully this works.
At TEP UK, we want to embrace this opportunity of the future of digital, the future of autonomous devices, and robots fall into this objective and this ambition.
Robotics was not initially a key topic for the research center, but it has grown quite significantly. And now robotics is becoming a key part of the center and a key part also of the global R&D of Total.
I was pretty skeptical at the start of, as most people, of why are we looking at robots? Over this last couple of years, I really start to understand the skills and the competencies that you need to make this thing work.
I hope that the introduction of the robot is a bit like us getting our iPhone. It's then the apps that we develop and how we use that, so it's the start of something bigger.
Autonomous devices like the robots will lead Total E&P UK and will lead our industry to a more efficient way of working on our sites. We see the benefits of the robot as being also very much into improving the safety on our sites.
TEP UK has an history, I would say, of innovation, and they're known to pioneer new technology.
So we have the vision within exploration and production to remove all personnel from offshore, have them doing different roles onshore, so there's more remote monitoring and control.
The vision of robotics with OGTC is very much around how do we fit into the future of oil and gas. We're looking at transitioning into a new era and looking at how we can make our fields more efficient, increasing our safety performance and also taking people out of hazardous and extreme environments. Robotics will play a key part of that, and that's why we're really interested in any technology that will help deliver that.
Total decided to launch a robotics challenge. Total at that point didn't have much knowledge of terrestrial robotics. We were able to prove some autonomous functionality, which was quite new at that time.
We started working with Total 2014 when the Argos challenge was starting, and finally winning the challenge paved the way for another project that we are currently in.
This year is very exciting for us. We are doing a lot of on-site trials and tests, and then we will hand over 2 robots to Total, which will be tested on a continuous basis for 12 months.
Well, my job really here is to facilitate. I want these guys to be given the platform to advance their technology so we can utilise it for real out there in the industrial world. These robots could be utilised heavily because they have got eyes, they've got ears, they've got noses, and they've also got thermal photography, which adds another vision that even we don't have.
We'll be able to collect some data, which will be then transferred to the cloud of Total, and we are developing at the moment some dedicated machine learning algorithm to use as best as possible this data.
I think one of the big benefits the robot provides is the ability to take measurements and readings that we as humans just wouldn't be able to do otherwise. For example, we can make use of the microphones inside the robot's sensor head to listen to the sounds that are being made by processing equipment, fans, motors, compressors, and we can use that information to determine if there are any defects or a gradual degradation in performance. Ultimately, that allows us to then intervene on equipment preemptively rather than having to wait until the point of failure.
If you look at what we do subsea, we send remotely operated vehicles, ROVs, down, and the ROVs do all our inspections, they do all our repairs, and what I see is the robot is essentially the ROV that's on the site. Actually, this is just the next evolution of that technology. It's just now hitting the actual beach itself as opposed to being underwater.
As we as Total start to understand the language and understand the technology, we're starting to understand the way that we can drive our business forward. And at the same time, with the very fledgling landscape in the region, start to support that landscape and starting to see a lot of other companies coming into that space.
The robot will be an additional tool that will be used in particular on the unmanned platform, because we'll be accessing to the platform at any time during the day or during the night without the need of sending operators.
Robots are very efficient when they evolve in an environment that has been designed for them. On this site, the human presence will be, of course, more limited. There will be some sort of, I would say, job transfer with the creation of jobs that are not existing now, but I think there will be more of a support and they will increase the safety of the site.
Coming in the near future are robots and will be ready to join our operating teams on our sites offshore.
Right. Hopefully that worked. Hopefully you can all still hear and see me. Why was that video important? Well, first of all, you can figure out that I'm from Total. But secondly, it doesn't matter if I'm from Total, from BP, from Shell, from SSE Renewables. It's about the fact that the thought process is changing in terms of how do we integrate robotic systems into our business, but also how do we have to transform our business to maximize the value of robotic systems, both in today's facilities through digital transformation, but also in the future, how do we design our facilities to accommodate more RAS systems? And that's part of the thinking that we have to evolve from. We talk about ROVs and we talk about digitalization in the past, which is effectively the sat-nav stuck on the screen of a traditional car. What we're really having to contemplate with now is digitalization, which is the Tesla, where you might argue that Tesla just happens to put some wheels on a computer rather than building a car and putting a computer in it. That's important because it's, for us, one of the building blocks of the transition. We have to have a strong digital competency, so that will enable the maximum benefit of RAS systems, which then in the future enables the maximum benefit of offshore energy. And that comes through better contextualized data, lower emissions, but also starting to be able to prepare for dynamic management in terms of logistics and energy. So as an analog, Formula One really springs to mind. This was a couple of slides taken from 2014. And the most important thing for me was that just in the US Grand Prix, one team generated 235 terabytes of data, 243 terabytes of data from that one race. Do we do the same from our operations? And technically, they've already figured out where they're going to come in the race before they even start the race by running real simulations and using those simulations with real data to inform the driver how to outperform the race in the race. So effectively, the race is finished before it starts, and it comes from collecting a lot of data along the way. But one of the most important parts, apart from data, which my data scientists used to tell me was data, is the optimization, the technology, but the key part is the rules. And that's a little bit where Alter kicks in. It's the boring part of the TRL scale. It's the integration part. And funnily enough, when it comes to the Formula One analog, we have all the same elements in offshore energy. So we already have real-time telemetry. We already have full software in loop simulation. We have the dashboards. We have the digital twin integration, and we have the data lake storage. It's all operating. Maybe the difference is that we're not quite at that final phase of industry pool. We've learned, we understand how we are to integrate it. We've got the technology through ORCA. We've got the demos to a certain degree through OGTC and ORE. But what we don't necessarily have is that industry pool at the far end, where Alter proposes to offer that through systems integration, through competencies, and through data and insight. And that specifically is writing the rules and the design standards to enable that to happen. So Alter is really proposing to be that front door entry for offshore energy organisations. At the moment, there is no one entity accountable for offshore industrial RAS. We've been working in that area for quite some time, and we've engaged across the board with OGTC, ORE, with ORCA, with the National Robotorium, and a number of other stakeholders. But what they're all designed to do is to look after something else. There's nothing really there designed to be that one-stop front door for industry, where it can get its knowledge management from in terms of the technical standards, the testing and certification of vehicles, and generating that ecosystem. Now, everyone tends to talk about data, and there is data out there, but at the moment it's very siloed. Even in the work that we've been doing in the past, we have performance data coming from the vehicles, we have payload data coming from the vehicles, and we have the digital twins. But what we haven't done is really connected it all through the industry. And by doing that, we are starting to enable a digital service, effectively that virtual wind tunnel, where you can start to drive vehicles in real life simulations, collecting data, and generating that lessons learned through the machine learning. And the important thing is that this is not, from an industry perspective, living labs or demo activity. This is actual site data that we want to collect. For example, in the top right-hand corner, you can see the ball valves through machine learning. It's all very well training an algorithm to recognize a cat, because you can go into Google and you can get 10,000 images of cats and you can train the algorithm. If you want to train it around a ball valve or a specific level of corrosion or a crack or an EX box or a compressor, that data is not so readily available. And therefore organizations really need to start clubbing together to get that training data. But by also providing that training data, we can test third-party algorithms to see which one has the best for whatever situation that we want to use it in. When it comes to the competency side of things, it's maybe that last step in the TRL in terms of what is the design standard? What are the operating guidance? Are we going to paint them all yellow, or are we going to paint them all white? What's the weight? What's the comms standard that we're going to work to? And that cuts across the board, because as you start to engage with the defence industry, the renewables, the oil and gas industry, we all have the same questions, but there is no one conducting that opportunity at this point in time. And as we move more into those systems, the fully end-to-end autonomous systems, we need to have that third-party verification and certification. A lot of the end users want that experience of buying off the shelf and knowing that it works. Who's certifying that it works, and who's providing that feedback loop, especially when it comes to reliability testing. Will it go up and down the stairs 10,000 times without falling over in 100 knot winds, or in minus 20 degrees, or in 35 degrees positive temperatures? So we really need that crash test facility effectively to deliver that. And that's one of the things that we've found with that video that I showed that's a few years old now. We're now at the point of putting these devices on our facilities, and it can be oil and gas, or it can be floating wind as well. But when it comes to we need it repaired, where can we get it repaired? Where can we get the warehousing and the 3D printing to enable that repair mechanism? At the moment, all these devices are pretty much European or American, so we're having to ship them out of the country to deliver that service capability. We really need to have that in this country. So what we've proposed is the ALTER program. It's not about new facilities, it's about bringing the existing facilities together and having that joined up front door where industry can enter the door and it becomes the feeder entities to responsibility to deliver that solution. And at the same time, there is one entity as a service centre that's looking after the services and the at-scale adoption that's required through either the collation of the data that we need, and by providing that data in a data trust sort of a scenario where we can work constructively together to maximise those insights, or on payload data where we can share a lot of that data that's not confidential to enable new machine vision third-party services to be kick-started. And on the competency side of things, we have a voice that starts to bring together the standards and specifications, the testing sort of requirements, and nurturing those sort of startup sort of entities towards the end. So what we see is really it occurring over 3 phases. Phase 1 is a working concept, which is also around about the economics and the understanding of how best to achieve this, but getting in the architecture so that we can start collecting data and start showing some of these insights and collating a lot of the knowledge that's out there, be it through the IEEE, be it through the Sprint robotics, through the varying BP, Shells, Totals, SS Renewables and others, Subsea UK, etc. that's out there. That's about a 12-month program. Second phase is probably a 24-month program where we really start to build a reputation around what we're delivering. And in the third phase, we progress towards an industrial centre and potentially start to look at investing in future facilities. But those facilities, again, would be located where needed and potentially around the existing service centres that are available at this point in time. And on the left-hand side there, you can just see the building blocks as it starts to build up through the data hub and competency hub into some innovation space, and then ultimately in the green at the bottom, providing commercial services into industry. And that's me done on that one. Over to Dan.
Brilliant. Thank you very much. I'm going to try my video again quickly. Still no. Oh well. Okay. So thank you very much, Dave. And thanks for bringing forward those hugely important challenges. Maybe not as flashy as some presentations that we see about, you know, robotics falling over and so on. Oh, I got video. There we go. Brilliant. But the organization of data, you know, data standards, defining levels of access is key to creating those future products, services, skills that the UK is looking for. And yeah, cheers for the F1 metaphor. Sorry, go ahead, Dave.
Sure, yeah, it's the boring part that comes next. Of, you know, we've seen all the demonstrations and everything else. To commercialize it at scale, you've got to really look at the integration, and a lot of the energy companies have really been reflecting internally how to deliver that integration, be it digital twins, be it data lakes, be it clouds, etc. And I think now we're at the point where we can start to engage constructively and start to shape a direction.
Yeah, and boring is not bad. There used to be a saying in a previous life, boring is good sometimes. You need that, you need those standards, you need that organization.
It's the bit that makes money at the end of the day.
It really is. And yeah, I only got into F1 a little bit once I started learning about the data side, and it makes it hugely more interesting from my point of view, rather than people going around the track. There's so much more to it. And thank you everyone for the questions. I've been keeping an eye on them. We've had to, unfortunately, David Layden has dropped off. He's mine in high demand. So it's myself, Dave McKinnon, and Rebecca Allison for a Q&A for our last maybe 10 minutes or so. And one straight off the bat for Rebecca is what do you think are the main CapEx reduction lessons learned from oil and gas? And how do you see them potentially being translatable to offshore wind?
Oh, the good old debate about CapEx, OpEx. Oh. So one of the challenges we do, and something that we've been working on is around this whole design for the future, and that's a kind of challenging in its own right, especially in the renewable sector. There is a different price, different commercial models. So it's almost that looking at it at the full life cycle. And most of us are now coming round to that, saying, well, actually, if we don't invest now, we're just storing up the problems for later on. And even for decommissioning, because even then when oil and gas went in, we didn't really think about taking it back out again. And now we've got the headache of a huge cost burden coming to towards us. But it's also the renewables have that problem coming too. So I do think the lessons learned are some of the challenges we're going to have. I think sometimes it's a bit too late because we've kind of gone down a road, but I think we do need to start thinking about alternative materials. And that's where, working with some of the other national centres, like the Composite Centre, and that, looking at those types of materials that we can bring in, but they have to come in with a proper cost base associated with them, because that's the thing. I mean, one of the talks we've had a lot in the past is around why do we always end up with carbon steel? One, we know about it, we know its properties, and it's cheap. And it's cheap to replace as well. If you do, you have to come in it with a different slightly, yes, we can go and I was speaking to a developer today about manufacturing something out of titanium. Yeah, it'll last forever. But the cost of it's too high. So you need to look at that cost benefit analysis and really understand the life cycle of the asset. So yeah, it's not the easiest questions to answer.
It's not, apologies. We can thank the audience. And maybe a slightly easier one would be OpEx. What lessons learned do we think we can apply from how we're making oil and gas assets last longer? How can that be applied to the offshore wind sector? Maybe through digitalization, or what's your opinion?
So from our perspective, from a technology point of view, there is alternative cost base, especially for repairs, looking at alternative repairs. We do not need to take things back to its original state if we've got a 5-year life cycle to go. Can you run a bit more for run to failure type analysis, fit for service type? So using data analytics to really understand what that actual condition is, because again, sometimes we can be a bit conservative and we go after the repair solution and some of the operating costs go higher when we don't necessarily need to do that. So using the whole data analytics side to actually understand where the risks are and looking at it at cumulative risk rather than just an individual risk, which is kind of what the GDI project has been looking at, is looking at it as an overall asset condition. And we've been working with a company, Excelos, which is based in Switzerland, and they're mathematicians. They are not integrity engineers, but they have been looking at how do you use data and finite element analysis more effectively and a lot quicker, so reducing the cost base from OpEx from that side. But maybe Dave's got some from his background, and maybe Total about aging assets and lessons learned.
Go ahead.
CapEx and OpEx, it's always a challenge because you've got to remember that hindsight's a great thing when it comes to developments, and it's also at the time there's a balance between a CapEx number that equates to a threshold of moving a project forward versus 10 years down the line when it's built and wanting things differently because you can look back on things. What we've certainly seen from a sort of facilities of the future perspective, if we can encompass robotic systems and remove the human element, and that can be from fire and gas systems to handrails to walkways to human accommodation, you can certainly reduce the capital cost of facilities by anything up to 20% quite readily. And it's the same with OpEx. If you're reducing the number of helicopter flights or the number of manned visits to an installation, you're reducing the cost. But the most prevalent way to reduce cost is the boring thing. It's data, data, data. Once you understand the data and you can start to predict things, then you can optimize your maintenance routine. And that can be anything from the simple case of looking at the weather forecast and trying to figure out why have we got guys working outside with cold hands, freezing cold, having to go for a cup of tea every half hour or every hour, when realistically, if we programmed the maintenance a little bit different, that they were outside on a sunny day and that they were getting a higher sort of production efficiency and they were in a module or doing something a little bit more enclosed in a bad weather day. But you can extrapolate that into a much sort of further end where you can get into predictive corrosion and looking at the digital twin and looking at your maintenance campaigns. And as you start to do that, you can also start to package up contracts, which means that you become more competitive. Or if you're able to share that data with some of the other facilities in the region, you can put a bigger opportunity together for the supply chain. So it's different elements, but it all comes back to data and being able to anticipate.
Brilliant. And there's another similar question saying, is there an aspect to this that's maybe behavioral rather than technology based? And if that is the case, it might not be. Would we want to change this? And if so, how? Whoever wants to pick that up, go for it, Rebecca.
So it is actually, there is a huge amount of work being done around the human factors of, especially from our OGTC, when we've looked at technology adoption and deployment, there's a huge element, and not just from the management and change from a corporate side, but from an individual's point of view. We actually have sponsored a PhD with Ruby Roberts, a psychologist, on what is the human factors, and some of it is around motivation and what's in it for me type thing from an individual point of view. And they are quite difficult elements to deal with, because some people just don't want to take the risk, because I don't know if I take on new technology and it fails, am I going to get blamed for it? Or there's sometimes also the factor around, well, it's not proven, so why would I be first? And a lot of people talk about, oh, I don't want to be first. We haven't seen that. We have seen lots of companies trying new technology almost behind closed doors, so they do it without telling anybody, just to see how it gets on. And obviously, if it does successful, they will shout about it. So the whole reducing and being the smarter future will have a lot around the human factor side, but that is always the challenging bit. There's also the bit around regulation as well. Some people do obviously have some nervousness about pushing the envelope around the regulatory point of view. Obviously, oil and gas has some more stringent regulations. So obviously people stepping out of that for technology, it's maybe not quite qualified or certified, obviously comes with a little bit of uneasy as well. So different elements, but I think that will just come with people getting more comfortable with new technology. We are all the same. I don't know if any of us are ready to get into a driverless car, as Dave was talking about earlier. You know, we are all familiar with the concept, but I don't know if I'd be getting in one right now. And I would say I'm pretty gung-ho and say, yeah, I'll try anything, but don't know, especially I certainly wouldn't put my kids one, but I'd sit in one as long as I had full control. Yeah, so that's the thing, isn't it?
I think, yeah, really pushing the need for validation, verification systems, and standards out there, something which ORE Catapult will be looking to get involved in the future, hopefully along with the OGTC. Another question on relatively similar.
I think can I come back to that one as well. First of all, mine already drives quite happily by itself on the motorways, and I've got no problem. The TLB was one of 5 organisations that did a data and digital survey in the oil and gas sector, and that was released yesterday through a webinar. And the main elements were around, it's probably something like 50% cultural change and culturally driven from the top and from below, and it's probably 50% around the technology. And some of the things to reflect upon are, certainly in the oil and gas side of things, we are very safe in our culture. We have to be safe, so we have to be pragmatic, we have to be step by step. And when you move into a digitalized sort of culture, there's a lot of fail fast, agile working and ways of changing. So you're seeing a very sort of juxtaposition cultural shift coming in. And as I said at the start, with digital, oil and gas has been digital for years. You know, a widget, a piece of technology that you can use, that works. When you start to move into some of this newer technology, which is all about that digitization, that full integration piece, you are engaging in a different cultural change that has to be led from leadership and from the bottom in terms of this is what we need and what we want. And it will take time. It's not something that will happen just overnight, but through the work of the TLB and a number of other organisations out there, that's what's starting to drive that reflection now, that there's an embedded understanding of what digitalisation actually means and a direction of which it can be translated into policy.
Thank you. And one last question to finish off with. So COVID-19 has had an impact on us all. Why we're not, in a room together today. Have you seen an acceleration in remote or autonomous and digital technologies as a consequence? It's just an open question to either of you.
Certainly the feedback we've been getting from our tech developers, ones that are a bit more mature on the TRL levels, that are more into the commercialised tech, have seen a big uptake recently on the whole remote operations, the digital sort of analysis piece, because people can't get off on sites. We have got restricted movements within the sector, as well as obviously everybody being at home. So we are seeing, or certainly the industry has said they have seen a big uptake to this. And I think it is, and it kind of touches into that whole behavioural thing as well. If we had said in February we'd all be sitting on Zoom and Teams calls all day working from our homes, we would all have said it wouldn't work. The comms don't support it. We can't do it. It will all be inefficient. Fast forward 6 months, most of us are potentially not going back to our offices for whatever reason. Some people have gone back part-time, some are going back different remits. So we quickly adapted to that, and our industry will also start to quickly adapt. And we are now seeing that from certainly the conversations we're having with some of our small developers that we deal with on a daily basis. Maybe from the TLB's point of view, Dave, you might have seen some from the industry's uptake.
Yes, I mean, without a doubt. Can you imagine if COVID-19 had come a couple of years ago, before Zoom and before Teams? We would have really been hurting. I think it was fortuitous that Teams in particular came in when it did, and it really is a paradigm shift in the way that work will continue in the future. And I think the use of robotics systems, the digital twins, the connected way of working will change the way that we do things going forward. And I think it's also a reflection that quite a lot of, I mean, it's not everyone's cup of tea, but quite a lot of people realize they get more hours in the day without having to commute. They get more actual thinking time and more engaging time working from home as much as they do working in the office. So I think overall, going forward, we will not see the old system. We will go back a little bit, but I think there will be a steady transition to that low-touch economy that people talk about.
That's brilliant. Thank you very much. Thank you very much, both, as well as David Lane, who had to drop off. That's going to be us for today. I'm going to pass back to either Ben or Vicky, probably for a lunch break until 1. But thank you very much to our guest speakers, and for everyone listening, the recording and presentations will be made available.